When humans come into a watershed and alter the landscape in that watershed or alter the stream channel, they change the characteristics of the biology. Some of the species that used to be there and abundant can't survive anymore, and others that used to be relatively rare become more abundant.
The changes we make in natural landscapes affect conditions in streams, as changes in our lifestyles affect our blood. But the effects of human activities on streams are complex and interrelated. As density of development covers more of a watershed, it fundamentally alters the flow of water as it makes its way down to the stream. Physical and chemical effects intermingle to transform biological conditions. Until recently, our efforts to protect water resources focus narrowly on chemical contamination. Preserving life was not the intent, though the Clean Water Act states this goal clearly.
Restore and maintain the physical, chemical, and biological integrity of the nation's waters. We used to implement the Clean Water Act as if crystal clear distilled water running down concrete conduits were the goal of the act. We now see that the goal of the act is really more accurately framed in the protection of biological integrity. When we have looked at rivers using biology instead of the historical chemical things, we find that a significant proportion of the fish species, of the mussels, of the crustaceans like crayfish, are threatened and endangered throughout North America. We see that in any river that we've looked at where there's substantial activity of humans, from 40 to 70% of the species of fish have experienced major declines in populations or they've gone extinct. Since biology is the primary endpoint of interest in human society, we need to measure that biology directly. One of the more commonly used measures and approaches now is to measure benthic invertebrates. That's insects and worms and clams and snails and other invertebrates that live largely on the bottoms of streams. They live on the rocks, in between the rocks, on the sand, in the sand, depending upon the kind of stream channel it is.
There's lots of them. And they also have a lot of unique life history strategies. Certain groups will key in on certain conditions. I think they hold tremendous promise to help us essentially diagnose the health of our systems and measure the change over time.
These biological measures have been shown to be very sensitive to a broad range of human influences. Chemical contaminants, watershed alteration, urbanization, logging, agriculture, grazing, and very complex mixes of all of those things.